Hello everyone and welcome. In this video I'm going to explain structs in C++ and more specifically the difference between a struct and a class, because I know a lot of people get those two terms confused, but hopefully after this video you'll get a good understanding of the difference. So first of all, what is a struct? Why would you use a struct? So imagine that you want to represent, for example, a product database. This is going to contain different products, and each product is going to be characterized by a series of fields. So for example, you want each product to have a name or a price or a brand name, for example. How would you represent this in your program? Well, could you use a vector? Well, not really, right? Because you might want your name to be a string, but your price to be, for example, a float or an integer, right? And inside of a vector, you can only represent elements of the same data type, so it doesn't really work. Now, could you use a vector of vectors? Well, sure, you could represent different data types in different parts of your vector, but it would just become really messy. And this is where structs come in. So structs are a way to represent aggregated or connected pieces of data of different data types. And then you can create an abstract data type like the product database I was talking about that has different fields inside that characterize it. So how would you do that? Well, you would write struct, and then the name of my struct is going to be database, for example. And inside of here, you can define the fields that characterize this database. So for example, you could have a string name, or you could have an int price, and you could have another string called brand name, like this. So now you have a data structure, which is our database, which is going to have different pieces of data that are connected, that could be about the same product and used to characterize it, right? Now, notice that this is very similar to a class. So you might be wondering, when should I use a struct and when should I use a class? Well, if you want to have an object with some more advanced functionality, you would use a class, right? So for example, if you want to code a player for a game that you're making, you wouldn't use a struct, right? You would use a class. So you could still have attributes in here. So for example, X, Y, a speed, but you could also have, for example, movement mechanics, and you would write a method for that, right? Or you could have, for example, shooting mechanics, and you would write a method for that, right? And it doesn't really make sense to represent this as a struct because you don't really only want to represent data, right? You actually want to have an object with specific operations. Whereas a struct you would use actually as a data structure, as a way to store data. Now, keep in mind that this difference is merely conventional, right? So there's nothing you can do with a class that you can't do with a struct. You can still have attributes inside of your struct. You can still make them private or public. You can still have methods inside of your struct. So all of these differences are conventional. Now, there is one technical difference between a struct and a class. So let me create here a player. I'm going to say player, like so. And I'm going to say player.x is equal to 5 and cout player.x. So as you could probably already tell, this is going to give me an error here. It's going to say player x is inaccessible. Why? Well, that's because every attribute and every method that you define inside of a class is going to be inherently private, right? So you can't really access it outside of your class. If you want them to be public, you would actually have to write here public, like so, and let me just indent this. Now these would be public, right? So I can actually access them from here, and if I actually run this code, this is going to output 5, which is the x coordinate of my player. Now inside of a struct, it's the absolute opposite, right? So everything inside of a struct is going to be inherently public. So I'm going to delete this. I'm going to say database, and I'm going to say product1, for example, and then I'm going to say product1.name is equal to choose, and then cout product1 dot name, something like that. And if I run this, this is going to work just fine, right? It's not going to give me any errors because these attributes are going to be public. And if I want them to be private, I have to specify that I want them to be private, right? So all of these are going to be private now. And this is going to throw then that error I was talking about because the name is now going to be inaccessible outside of my struct. So that is the technical difference between a struct and a class. So I actually undid that because there's a couple more things I want to show you. So let me just finish coding this product right here. I'm going to say product1.price equals 4, for example. Product1.brand name is equal to something random, I don't know, cookie or something like that. It's hard to invent brand names on the spot like that. And let me create here another product. I'm going to change this to be product2, and I'm actually going to leave it the same as product1. Now, if I want to compare both of these structs, I can't really use the equal operator, right? I can't really compare them directly. So I can't say something like product1 is equal to product2, then cout true. I can't say something like this. This is actually going to give me an error. If I hover over here, it's going to say no operator equal matches these operands. Right? I can't really do this. If I want to compare them, I have to compare property by property or field by field, right? So I have to say product1.name is equal to product2.name, and then product1.price is equal to product2.price, and product1 dot brand name is equal to product2 dot brand name, right? And if I actually run this now, this is going to output true, right? Because they are in fact equal. There you go. That took a while. So that is how you compare structures. You actually need to compare field by field. And the last thing I want to show you is how to create an array of structures, because you can actually do that. You can say something like database. This is going to have 2 elements, and this is going to equal product1 and product2, like so. And this is actually a vector of structs of, well, databases, right? So I can say database 0 dot name. And I can see out that, and if I run this now, this is, let me run that again, this is going to give me the name of the first product in my database, which is going to be shoes, right? And I could also say something like cout database 0.name is equal to database 1.name, right? And I can also do the comparison like that. I actually need to put parentheses here because I want to see out the whole statement. And now if I run it, it's going to output true. So that is how you compare structs, and that is how you make an array of structs. Now you could also make an array of, for example, pointers to structs. That goes beyond the scope of this video, so I'm not going to really talk about it. And that is all I have to show you today. If this video was helpful and easy to understand, please like and subscribe to support the channel. Thank you so much, and I'll see you in the next one.